Okay. Hello to Caitlin and Sadie. Caitlin Hendrickson. It's gone. Yep. Started. We are on 21, 22, 23, 24 seconds. 24 seconds of wasted time so far. All right, here we go. So, you know how to, if you haven't filled out this chart yet, fill that out, okay? Not right now, but like this weekend, as you're going over your assignment, because you learned all these, right? So now it's time to fill these out because they're all on your sheet. So anybody have their sheet from yesterday? No? Okay. Oh, yeah, that. So your worksheet from yesterday has the answers to all of these. Okay? So like the very first one you did was pi over 6, right? So that was your 30-degree mark. That would give you your terminal point. So you can fill all that out. Sid, right? You just said, oh, so. Connects now, right? Connects now, right? There you go. So make sure that you do that. We are going to quiz on this next week. And trust me, we'll make sure you're really good at it. You'll practice in class. You'll have to partner up. You'll try to beat your partner. It'll be a good contest. Usually a few fights break out, yes. A lot of aggression. Today we learned our last part of 5.1, which is the definition of a reference number. Reference number is the shortest distance from the terminal point to the x-axis along the unit circle. You do have to be able to use reference numbers quite often later on. And this is just a good time to practice them. We will review reference numbers later on when we actually use them. But right now it's just something that your brain is kind of ready for, so we're going to use it. So it says if t is equal to 2 pi over 3, we have to answer that question. What's then the shortest distance between that terminal point and the x-axis along the unit circle? So I'm just going to draw a little unit circle here. Okay, so I got my labels. And now I'm going to travel 2 pi over 3. 180 degrees divided by 3 is 60. So I'm going to travel two 60-degree measurements. So travel 1 pi over 3 and 2 pi over 3. If you look at the definition, it says the shortest distance between the terminal point and the x-axis. It's always the x-axis. You tell me, which would be a shorter distance to travel, the blue distance or the green distance? The green. So we have to figure out is how far would you travel to get from 2 pi over 3 to pi? Pi over 3. If you rename pi as 3 pi over 3, you can see that you would simply have to travel pi over 3 further to get to that spot. Right? That's it. So the reference number is pi over 3. You probably shouldn't use an equal sign because it's not equal to. But that's your reference number. Reference number is pi over 3. There we go. Oh. Let's do a couple more examples. These are a little bit more involved. Let's do a couple more examples that are like that to make sure that we understand it quite well. Okay. I have space over here. You guys have space over here? Let's go there. Got it. Thank you. Okay. Let's do 5 pi over 4. 5 pi over 4. Pi over 4 is how many degrees? 180 divided by 4 is 45. So I travel 5 45-degree increments to get to that spot. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. I want to travel along the unit circle to the x-axis. I could travel along the I could travel along the blue route, or I could travel the green route. Obviously, which one's shorter? The green. Yep. If you see, this is 5 pi over 4. That's that distance. And pi is the same as 4 pi over 4. So, how far between the two? Pi over 4. So your reference number is pi over 4. Quinn. Either way, it's pi over 2. So Quinn's question is, what if I land on the y-axis? Either way, it's pi over 2 in either direction, isn't it? And then the other question was from last hour, what if you land right on the x-axis? And you're there, so you have to travel 0. So, okay. Let's do one more before we go to the little bit harder examples. Negative 11 pi over 6. 0. This would be negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Can you tell by looking at negative 11 pi over 6, is that going to be more than one full rotation? Not quite. Negative 12 pi over 6 would be the same as negative 2 pi. So if we went to negative 12 pi over 6, we would make one full rotation. So like negative 13 pi over 6, negative 14 pi over 6. That would be more than one full rotation. This is going to be short of one rotation. 180 degrees divided into 6 parts is 30 degrees. So we're going to do 11 30-degree increments in the opposite direction. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4, 5, 6 pi over 6, 7, 8, 9 pi over 6, 10, 11. We traveled a total of negative 11 pi over 6. That's what that is. Now, if I traveled, did I travel a negative amount? I know that we actually went in the negative direction, but we're talking distance here. So is the distance actually negative? No. So you actually went. We ended up at the negative 11 pi over 6 spot, but you actually traveled 11 pi over 6. And we know that the full distance would be 12 pi over 6. And so you have to decide, is the shortest distance the red or is it the green? And it is the green. So how much further would you have to go? Simply a pi over 6. So pi over 6 is the reference number. Is it clicking? Yes. Yeah. Okay, good question. Exactly. So when we have pi over 6, so like in that situation, we said that was 30 degrees. And because this is a 9, so each quadrant is 90 degrees. If you have a 30-degree spot, you're going to travel 3 within each one. If you have a 45-degree spot, you'll travel 2 within each one. If you have a 60-degree spot, then travel 1.5 between each one, or 3 within the entire piece. So really dividing up those fractional pieces of your pies is kind of what makes a lot of stuff click. And we're going to come back to this over and over again the next week. And then we'll kind of put it aside and hopefully it'll lock in. Any other questions? Good question. All right. T equals 4. We'll do these two examples, and we'll be done for the day. T equals 4. What's different about that compared to the other ones? There's no pi. Now, that's okay, because you could have t be equal to pi, which as a decimal is 3.14. So instead of labeling our x and y axis with pi, let's label it with decimals. And we can see where 4 ends up. So this was 0. This was pi, or 3.14. What would the decimal be for all the way around then? Twice that, 6.28. Now this spot we called pi over 2. You would take 3.14 and divide it by 2, and you get 1.57. So if you travel a quarter of the way around the circle, that's 1.57. So 1.57 plus 1.57 plus 1.57 makes 4.71. So you're gonna, now it's like, not only do you want to be able to understand the difference between degrees and radians, but we also want to be able to understand the decimal value. Okay? So there we have it. So 4, if I travel a distance of 4, which quadrant is it going to put me in? Third, between 3.14 and 4.71. It really doesn't matter where, as long as you know the quadrant that you're in, because the shortest distance is either going to be the blue line, the blue arc, or the green arc. Which one's shorter? The green. So that placed us at 4. How far did you have to travel to get from 3.14 to 4? Yeah, you would simply take 4 and subtract 3.14. And you get 0.86 approximately. So it doesn't always have to be in terms of pi if it's listed as a decimal. Always travel to the x-axis, never to the y. Just like before you always drew your triangle to the x-axis, always travel the x-axis. Always. Okay, last one. T equals negative 3.62. So same type of problem, just negative now. Well, we kind of did an example like this up above. Now this would be negative 1.57. You would travel 1.57 the opposite direction. So negative 3.14, negative 4.71, and finally negative 6.28. So if you travel negative 3.62, which quadrant will that put you in? Second quadrant. So I start here, travel negative 3.14. I need to go a little bit more. Now, it says that I have a location of traveling negative 3.62. What's the actual distance I've traveled? I've traveled 3.62, okay? That's how far I've actually traveled to get there, okay? Is the shortest distance the red, or is it the green? It's the green. And so, don't worry about the negative, okay? So, I've traveled 3.62 to get here, and it's 3.14 to get to the x-axis. So all I want to figure out is how much further past that x-axis did I travel, subtract the values, 0.48. So, good? All right. So the other day, I also assigned 29 through 34 on the video. I kind of took that back. We will still cover 29 through 34, but we're going to cover it with the problems 25 through 34. So this is all about reference numbers. You're also going to do a couple terminal point pieces. I really do want to, encourage you guys to have a nice, little stretch here, where you're able to take a little break this weekend. I know you got Winterfest. I know you got games and stuff going on as well. Just remember that in a couple weeks we do have a full week of spring break, right? So you are going to catch a break then as well. So you're going to set trig down for an entire week basically coming up here. And trust me, when we get back to it, we'll have to review a little bit. So make sure that you at least do some trig between now and Tuesday morning. That way it'll stick in your brain a little bit better. So that's it. Happy Valentine's Day. Too bad that Caitlin and Sadie missed out on all the treats we had. I think this is the most number of treats we've ever had in class, right? Like, I might be sick later from all the cupcakes I've eaten.